Okay, so we are going to continue with the Pythagorean theorem and talk about some real-life applications of it. Okay, so we remember, I'm not a big fan of, but the a squared plus the b squared equals the c squared. The a, the b, and the c come from the names of the angles, or the labels of the angles. So if we have Pythagorean theorem, a squared plus b squared plus c squared is assuming that c is the right angle, so capital C, capital A, and capital B would be the other two angles. We also know that if you have side A here, or excuse me, angle A here, then side A is going to be a little letter, lowercase. Opposite side C is little c, and opposite side B is little b, with C being understood as being the hypotenuse. I'm not a big fan of this because you're not always going to have A's, B's, and C's. So I rather think of it as a leg squared plus the leg squared equals the hypotenuse squared. Because it is a hypotenuse, you know that it has to be a right triangle. So it must be a right triangle. So if we're doing Pythagorean theorem applications, we know that somewhere in our diagram, you're going to have a right triangle somewhere. So if we are talking about a football field, so I'm going to just kind of paraphrase the story. If you have a football field, or a piece of a football field that is 520 meters long by 125 meters wide, then what is the length of the diagonal? So a quick refresher with what a diagonal is we're going to draw this picture. So our football field is going to be a rectangle. If I'm talking about a diagonal, I am looking specifically for that piece. I know it is 520 meters long and it's 125 meters wide. Because it's a rectangle, we also know that it's going to have right angles. So what I am actually focusing on is what is the length of the diagonal, so I'm looking for the length of that piece. So I am going to be actually focusing in on that triangle right there. So I have a leg squared. So we have the right angle here, which means that we are looking for the hypotenuse in the pink triangle. So I have the leg squared, it does not matter which one, plus the other leg squared has to equal the hypotenuse squared. And with my calculator, I guess I could have picked some smaller numbers. Yeah, I should have picked smaller numbers, but we'll just go with it. 270,400 plus 125 squared is 15,625. That is going to equal the x squared of the diagonal squared. Add those two numbers together and we get 286,025. Remember how we solve for x is that we have to square root to get rid of the squared. So x is going to equal the square root of that number. So it's going to be about 534.8 meters. Okay? Oopsie, can't see it. Okay, let's go ahead and do another application problem. Okay, so if we have a tree, and I should see some kind of representation of a tree. If you have a tree that is casting a shadow, shadow is always on the ground. So if you have a tree that is casting a shadow, which means that the sun is up here, Okay, casting a shadow, and you know that the shadow is 16 feet long, and you know that the tree is 20 feet high, and for some oddball reason you are trying to find this measurement. Okay, so we're going to use the same format. I'm not going to solve this problem, but you would do the leg. So hopefully you can see the understood right angle. We have the tree there. So we have 20 squared plus 16 squared is going to equal your x squared. Okay? You're not always going to be looking for the hypotenuse. So let's say that we are, last one, let's say that we are pitching a tent, and we have the tent staked out here. I don't know what it would look like, but you have to stake it over here. And you have 20 feet, like at 25 feet of cable or rope or whatever. So this is our tent. And we know that our tent is 9 feet tall. Then how far can I place the stake if I only have a 25-foot piece of rope? So that would be my x, or the leg that I'm looking for. So the leg squared plus the other leg squared would equal the hypotenuse squared. X squared plus 81 equals 625. Subtract 81 on both sides. X squared equals 544. And I'm going to take the square root of that and get about 23.3 feet. That's what you're going to be looking at with trig applications. Or excuse me, Pythagorean theorem applications.